In this video 2-1, we will be solving one-step equations. By the end of the video and work time in class, you should be able to say, I can solve one-step equations. Some vocabulary here. Equivalent fractions are equations that have the same solutions. If you have equivalent equations, they are equations that have the same solutions, which we are going to get into by using the properties of addition and subtraction with equality. The addition property of equality says that adding the same number to each side of an equation produces an equivalent equation. So if we had A is the same as B, if I took and added C to both the left and the right side, it would remain the same. If I had x minus 3 is the same as 2, if we take and do x minus 3, add 3 to both sides, it would remain true. The subtraction property of equality states the same thing, however, with subtracting. Subtracting the same number to each side of an equation produces an equivalent equation. So if we had A is the same as B, and we take away a value, let's say C, from the left, and we do the same to the right, it remains true. For example, if I had x plus 3 is the same as 2, and I take the left side, x plus 3, subtract 3 from the left, and do the same to the right, it would remain true. And essentially, whatever we do to one side, we do to the other. To solve an equation, you must isolate the variable. You can isolate the variable by using the properties of equality and inverse operations. An inverse operation undoes the other operation. So if we have addition, the inverse operation of addition is subtraction. They are inverse of each other. They're opposites. If we see multiplication, the inverse of multiplication is division, and vice versa. The opposite of division is multiplication. What is the solution? If we have 15 plus s is the same as 42, we want to get that s all alone. So we're going to subtract 15 from both sides. Once again, using that property of equality, whatever we do to one side, we do to the other. 15 minus 15 is gone, so that's 0. So s is the same as 42 minus 15, which is 27 for our solution. Go back and check your work. Plug in 27 into the original equation. 15 plus 27 is the same as 42. And we see it's the same, so it worked. That's the correct solution. Negative 12 plus x is the same as 17. I want to isolate the x on the left side, so I want to get rid of negative 12 by adding 12. Whatever I do to the left side, I do to the right side. That is now 0. So now x is 17 plus 12, which is 29. We check our solution. So we're going to put 29 in for x. Negative 12 plus 29 is the same as 17. Find the difference, keep the sign of the greater absolute value. It's the same on both sides, so that is the correct answer. So make sure you're always checking your work. The multiplication and division properties of equality state if you multiply each side of an equation by the same non-zero number, it produces an equivalent equation. So if I had A is the same as B, and I take the left side, multiply it by C, and do the same on the right side, it remains the same. The division property says the same. By dividing each side of an equation by the same non-zero number produces an equivalent equation. If I had A is the same as B, if I take A, divide it by C, and take B and divide it by C, it would remain true because I'm doing the same to both sides. So if we have 2x is the same as 3/5, the whole point of this is to get the x all alone. So I'm going to rewrite the problem over here. To get that x all alone, right now it's being divided by 2, so I'm going to do the inverse operation. I'm going to divide by 2. Whatever I do on one side, I do on the other. So we have 3/5 divided by 2, which is 2 over 1. Turn it into a multiplication property, or a multiplication problem. Find the reciprocal. And 3/10 would be the solution. We check our work. We plug in 3/10 into the original, and 2 times 3/10 would give you 6/10, which reduces to 3/5. So that is correct. Number 4, x divided by 5 is the same as -12. So we want to undo the division of 5 to get that x isolated. The inverse operation of division is multiplication. We're going to multiply by 5. Whatever we do to one side, we do to the other. What happens is we have 5x over 5, so that reduces to 1. So we have 1x. We just don't put the 1 in front for a coefficient. -12 times 5 would give us a -60. We check our work. We plug in, see, -60 divided by 5 is 12, so that it, or -12, so that is correct. Five halves x is the same as 15. So 5 halves is being multiplied by x. Now, there's a couple things we can do here. We can look at this as dividing and divide both sides by 5 halves, but the other thing I can do is I can take 5 halves and multiply by the reciprocal, because we know if we multiply reciprocals we get 1, which is what we want on the left side, was 1x. Now if I multiply the left side by 2/5, I have to multiply the right side by 2/5. This all simplifies to 1, so you have 1x, x is all alone, and 15 times 2/5, then if you look at that would be 30 over 5, so x simplifies to 6. Come back, check your work by plugging in 6 in for x in the original, 5 halves times 6, which gives you 30 over 2, which is 15. Rob is driving at 40 miles per hour. Stacy's driving, and we have more here to add, and that is in the way, is driving 3 halves. So it should say that Stacy is driving 3 halves, so 3 over 2, times as fast. How fast is Stacy driving? So Stacy is going 3 over 2 times what Rob is going, which is 40. So she's going 3 over 2 times 3 halves as much, which would be 1 1/2. So she's going 1 1/2 times what Rob is going. And so what's 1 1/2 of 40? Well, if we look at this as rational numbers, if I reduce the 2 and the 40 by 2 divided by 2 is 1, 40 divided by 2 gives me 20. Multiply the numerators, multiply the denominators. So Stacy's going 60 miles per hour. Can you say, I can solve one-step equations? Write a summary and reflection and be prepared with any questions for in class during work time.